Okay, welcome folks. Last time we did a bunch of work with Helm and Kubernetes and Docker, and there were all these kind of pieces. We kind of showed like what does it mean to create a Docker image and push it up to the registry, and then we went and kind of fit that into Kubernetes and kind of looked at the code a little bit to go and figure out what all the environment variables are and stuff. Went into a little bit of the config. And so there were kind of all these pieces, and I hope kind of all of my little tangents that I went on fit together decently at least. So I got some new toys today, the best one. Got a new microphone. Hopefully the sound quality will be better. And I'm going to adjust the gain a little bit on this so that it's not so crazy. Not so loud. That's a little bit better. I'm super excited about my toy. I love things like this. That's cool. Got my tea. Got some backup water as well. So I'm good to go. Probably try to spend a little bit less time today than I did last time because that one went pretty long. So we're going to switch to display here. And yeah, so this is the one we created last time. It's still a work in progress. And let's go to the command line. And so I'm on master. I've got my code here. And just real quick, I am going to really quickly go to the makefile here and do a Docker. Do we have Docker in here? No. So I'm going to go and build the proxy and then push it up one more time so it's like fresh from master. So we're going to go into command proxy, docker build -t go mods. What is it called over here? We're going to head over. We kind of did this last time, but we'll just do it one more time. So yeah, right now it's called go mods /Athens. We're obviously going to be changing that sometime soonish. What do we need to do? Blah, blah. Forgot kind of how to do this. Olympus. All right, I'm going to basically copy this and going to paste it in here. And we're going to call this go mods Athens. And I'll have to go and fix this up and actually put it into a PR. Command proxy Docker file. And then, I gotta go up 2 levels, so we're at the root. So let's do that first. So what we want is we want to be at the root of the directory or of the project. The main reason is so we get all that goodness. Vendor has all the dependencies in it. So obviously we need those to actually build the program. So once again, I'm going to go in, I'm going to give this a little copy. Let's just create a scratch file so we can do this outside of the main show in the command line. So go mods /Athens. We want to build it from the proxy directory. So we want to use that Docker file, and that is over here, this one. It's fairly similar to the one in Olympus, but just want to keep things separate, especially because we got this going on. So yeah, we want to build the Docker, or we want to build from the Docker file, but we still want the root, because that's the thing that gives us that vendor directory. That's why, remember, we're executing this from the root of the repository. So the dot is going to be the root of the repository. So I'm going to head over to the command line. I'm going to actually do the build. This might take a few seconds, maybe a minute or something, because it's got to use yarn to pull down all of our amazing JavaScript dependencies. And before that even, you can see this going down. It has to send the whole vendor directory up to the Docker daemon. And even though that's on localhost, it still takes a little bit of time. And then this is actually doing the work to copy it from the daemon into the Docker, what is it? The builder. I think it's the builder. I don't know too much about like Docker build internals, but it's something like that, basically. So yeah, here's where we go into the proxy directory inside of the build. We're using Buffalo build. Buffalo build is obviously the Buffalo CLI. That's doing not only the Go build, but it's also packing in like all the templates and the assets like JavaScript and images and stuff. And it's outputting to /bin/app. If we go back into that Docker file, just go here. You can kind of see it's multi-stage. Oh, it says it even here. What multi-stage means is we've got this from, and all this stuff before the next from is staging a bunch of stuff. Really all that we care about staging is that eventually through all this stuff up to line 15, we get to all the things kind of in place so that we can build, and we output the app all built and all bundled together with pretty much everything it needs. That's going to be spit out to /bin/app. And then the next step here, this is the second stage. This is going to actually create the image that's ready for production. So you can see like when we do workdir /bin, that is going to set us up in the /bin of the new image, the one that's going to be production. And then this is the magic. We are copying from the first step, which we call builder. We're copying that into we're copying /bin/app from the first stage into /bin, which we set up here. And then this is some stuff kind of for production readiness. And then when we actually Docker run the image, by default, we're going to run /bin/app, which is exactly what it sounds like. So we got this going on. The run happened. Here's all the amazing yarn install stuff going on there. So basically, like this is the first stage. This is the end of the first stage. Here's the beginning of the second stage. Everything was good to go. This is that by default, this is what the final image, the one ready for production, is going to run. And now successfully tagged, that means we're ready to go. So now I'm going to Docker push go mod /Athens latest. That's the thing, again, if you remember from last time, it's going to send it up to Docker Hub. And shouldn't be much to do here. Docker images work in layers. So each non-comment line is a new layer in the Docker image. And so you can see this is one of the layers that has changed since last time. So the Docker Hub server, the one on the internet, it said, oh, well, the SHA of this is not the same as what we have. So you got to upload the new one. That's what's happening. And that's, in a nutshell, there's some more details under the hood there. Again, which I understand maybe 75% of, to be honest with you. So if you are not a Docker expert, know that neither am I. I probably know less than you do. So anyway, we're good to go there. And now we can get back into our Helm stuff. So we've got the Docker image up here now. Check it out. Just pushed it a few seconds ago. Just remember from last time, it's the latest tag, which is kind of a no-no, but for now we're just going to ignore it and be okay with it, I guess. So I forgot what the branch name was. Branch name was Helm. So we're going to go and check out the branch Helm. And I believe we are up to date with master because this is not clickable. I love the GitHub UI because you could just click that, and if there are no conflicts with master, it'll just go and update you, merge everything in, and your branch will be up to date with master. And then it checks again to see, now that it's up to date with master, the CI pass, can you deploy with Netlify? So it's exactly like if you did it manually on your command line and repushed. So just to make sure now that I know the remote is up to date with master, I'm going to do a git pull here. It's going to automatically pull from my remote, make sure everything's up to date on my machine, and it is. That's pretty cool. And now let's go back into Helm land. So really quick recap. We made this charts directory. Under charts, there's a proxy directory. We created this chart.yaml. Chart.yaml is like almost good to go. It has everything that Helm requires, but like a field like that, that's completely wrong. That's this, and we are not WordPress. But it's cool. We're just going to leave it like that for now. Not a huge deal. We also have like sources and maintainers are empty because I just don't know what to put yet. And then values. These are, if you remember, you can parameterize the Kubernetes YAML files. Those are the like actual manifests that go up to Kubernetes. And when you do a Helm install, which we're going to see in a second, Helm is going to send up this file along with all of those templates that look like this with all those squigglies. And then on the server, the Helm server, it's going to take all these defaults along with some stuff that you can pass in your command line. When you do a Helm install, it's going to take all that up, and then the server is going to put it all into the template, render the template, and then it's going to send it to Kubernetes. And then, so here, like this is sensitive data, so we're not going to show it in the defaults because you have to send that. You're going to have to set that on the command line. And then we've got, this is where the magic happens, basically. This is the deployment. If you remember, the deployment makes sure that n number of pods are running. And if you remember, a pod is one or more containers all in one piece, and that gets moved around the cluster. And it's kind of the smallest unit of deployment in Kubernetes. Okay, so on to the actual Kubernetes cluster. So we've got kind of two tools we're going to work with. The first tool is the Azure CLI, because I'm using Azure Kubernetes Service, AKS. I work at Microsoft, so it's free for me, and it's great. I don't have to pay for anything. I'm big on that. I'm big on free. So we're going to do this. We're going to do AZ AKS list-o table. And if you are an AKS user, you're probably familiar with this. This is going to list the Kubernetes clusters that I have on AKS. So press enter there. And there we go. So the one that I care about, I did a presentation in Portland a while back. And it was at the Cloud Native meetup. So I still have that running around, I guess. I should probably delete that. But I don't care right now. I set this one up. I think I set it up like 2 days ago or something. I was doing some testing. And I want to use this one to deploy onto. And it's a pretty recent version too of Kubernetes. So we can do this. We can do AZ AKS get dash credentials. And then Athens, we do dash name equals Athens dash proxy. Then we do dash G for resource group. And the resource group is called Athens. So what is this doing? This is taking all the credentials that I need for my CLI, my Kubernetes CLI, to talk to the Athens-proxy Kubernetes cluster. So now I'm going to go over and start using kubectl, Kubectl. People pronounce it differently. I pronounce it kubectl. And that is the thing. That's the open source tool. Everyone uses it, whatever Kubernetes Kubernetes cluster they're talking to, they use it to talk to the standard API of Kubernetes. So all the big three clouds run a standard Kubernetes, and you could use this on any one of those, or on local Kubernetes clusters, or pretty much any other open source Kubernetes you run. And by the way, all the big three clouds run the standard open source Kubernetes as well. So we can do this to make sure we're good to go. kubectl config get dash contexts, and this does what it sounds like. there is a config context that your kubectl will use. I forgot the L. And that config context contains like the endpoint of the Kubernetes cluster, all the auth for the Kubernetes cluster, and some other stuff too. So when we run this, we can see all the Kubernetes clusters that we have pretty much ever configured in this machine. So the star means I am configured by default to talk to the Athens proxy. So that's great. That's what we want. Next step is we're going to do kubectl get nodes. Kubectl get nodes shows me the actual VMs in Azure that are running, that are able to run pods. They're running this thing called a kubelet, which is like the worker that runs pods. So we've got 3. That's pretty cool. And they're running the client software 1.10.6. And these things talk up to a Kubernetes server, which is also in AKS. That's running the same version, which is good. But I don't really have to care about the server because just like Google GKE, the server is like managed for me. I don't have another VM running the server, and that's cool. It's a really nice feature, that one less thing I have to care about. Okay, so just a quick another step. You might want to do this. I have aliased kubectl to k. That's easier to type. So I'm going to do k get ns for namespaces, and you can see I've got 3. Obviously, you get default by default, and then kube dash whatever. Those are internal. You can look in there. They're pretty cool to play around with. There's stuff like internal cluster DNS, and that's cool to play around with. You can swap it out and kind of build your own distro, if you will. But I'm not going to deal with that today. So by default, you use the default namespace. So k get pods. Remember, pods is the smallest unit of deployment. There's no pods, so that's great. There's no pods in the default namespace. So that's awesome. Okay, now Helm, because remember, we're building a Helm chart. Let's go check out Helm. Again, it's at helm.sh. And if we go down here, we can go and check out docs.helm.sh. And you can check out, let's go to using Helm. And there's some prerequisites. We have a cluster. We're going to go figure out our security in a second, and then installing. So that's pretty important. So we did this already. Install Kubernetes, have access to a cluster. Security context. There is this thing called role-based access control. Honestly, it is a thing. It's very important. Understanding it is good, but honestly, it kind of sucks to deal with, if I'm just going to be completely transparent. So you got to do some steps so that Helm will work. And I opened that in a background tab for, we'll get to it in just one second. And we're going to go and check out the installation guide for the Helm CLI. So remember that Helm is a CLI on my machine and a server called Tiller in the Kubernetes cluster. So I also opened up the installation guide in the background. Let's go check that out. And I'm going to just use Homebrew because it's easy and fast. So I'm going to do brew install Kubernetes -Helm. I think I have it installed already, in which case I'll just do a brew upgrade. And Homebrew is going to do its thing. It auto updates. That's sweet. And let's see how long this will take. Okay, there you go. I already have it. But I've got 2.7.2 and we got a new version out. So let's do that. Take another few seconds for Homebrew to do its thing. It's going to download. I love the verbs pouring because it's like beer, I guess. But I also love that I type one thing, it just figures everything out. That's great. All right, so I installed it. They actually have a bunch of different ways to install. I've done binary release install. I've done the Linux install. I think there's an apt-get, so I've done that on Ubuntu, I think I had a Debian in the cloud somewhere. I did it once. I've used the script. I'm just bragging now how much Helm stuff I've done. Building it from source is super fun if you want to, hang out and do cool stuff. And this is the way that you install Tiller. So Tiller, again, that's the server that runs in Kubernetes and talks from the server in Kubernetes to the cluster, that same Kubernetes cluster. This is like the easy way to install it, but I'm going to deal with the security RBAC stuff first, because that's, in this case, that's kind of important. And remember, I opened up the security docs, I think here, no? Where did I open that up? Securing a Helm. What was it, here? That might be it. Nope. That link's kind of broken, I guess. Maybe that one is too. Securing Helm. Okay. Yeah, the default does no security. That's cool, I guess. I've had problems before, so it's kind of complicated to explain. RBAC, wave my hands, get into that maybe later or something. RBAC. And we're not going to go and use RBAC. Actually, that might be the doc. There is somewhere that has a really simple thing to do. Where are you? I'm going to go into the repository because I have seen it in there before too. Docs. I think it's docs RBAC maybe. Yeah. Okay. So yeah, this thing is installing like a service account. That's like Tiller is this user, and then it's installing this cluster role binding, and that is like the user's user's access kind of. We're giving it cluster admin, God mode essentially. So this is my amazing handy copy and paste. You saw me do a bunch of copy and paste last time. I'm not going to stop doing that now. So I'm just like blindly giving Tiller every God mode ever in the cluster. So like if you're really doing a production thing, probably don't do this. Probably like figure out RBAC kind of and do it the right way, or do it like the best way for your install, your organization. But I'm not doing that. I'm doing this. And I'm going to just save this maybe on my desktop as RBAC or tiller-rbac.yaml. And we got that going on. Get rid of that slash. And by the way, this is legal in YAML. So this is like one YAML file. This is another YAML file, and I'm just like putting them all in the same file on disk. And I'm just saying, hey, YAML parser, treat the above stuff as one and the below stuff as another. In case you didn't know. And then we do a kubectl create -f for the RBAC config. I called it something else, so we're just going to copy this. So let's do that. Kubectl create -f. I put it on my desktop. I called it tiller-rbac.yaml. Let's do that. Wait for it. All right. So yeah, this matches the first command. See, service count Tiller created. We see that down here. Cluster role binding Tiller created. We see that down there. So now, remember I did the homebrew install. So now I have Helm, user local bin Helm. Let's make sure it's the right version. So yeah, I've got 2.9.1. And what this is actually doing is saying, all right, I know the client version. It's compiled into the Helm client. And now it's going out and like trying to figure out what the server version is. And this is kind of funny because like the server, the Tiller, it has an endpoint to get the version, but I haven't installed the server yet. So this is going to hang, I think, forever. It might have a timeout, but it's super long. So it's going to hang forever. There's no server, so I'm just going to kill it. But the cool thing, if you look down here, the really awesome thing is you can install the server with the CLI. So you don't have to go and grab new like Kubernetes YAML and stuff. You just like do helm init. And I'm going to do that. I just copied and pasted. And there you go. So this got some nice logging. I'll get to this in 1 second. This is what you want to see, the server-side component, tiller, it's been installed. By default, it's deployed with an insecure policy. I believe that's the communication between the Helm CLI and tiller. I could be mistaken. But I'm going to hand wave. I want to get this working for now. I'll lock it down later. But spoiler alert, I'm not going to lock it down later. I'm just going to show this working, and I might even just shut down tiller after Athens is running. Haven't really decided yet. But anyway, this is kind of a demo anyway. And when we install this like as a real running proxy that everyone can use, obviously then I'm going to go and like figure all this stuff out. The other thing here is Helm Home. So Helm Home, let's just check out what's in that. So /users/aa//.helm. So that's what's in it. We've got a cache. That's what it sounds like. It caches charts. Plugins are binaries that Helm can run. Repo is a cache of the Helm repositories. I talked a little bit about that last time. Basically, a repository is an HTTPS server with a couple of endpoints, including ones to grab charts. And I forgot what starters is. I think this might be like quick starts or Clippy for Helm, like a wizard. I don't know. So that's that. We've got Helm installed, tiller installed, and I believe that's it. We're good to go. This is another example that, quite honestly, I don't care about these right now. You can just send me hate mail or troll me in the comments of this video or something if you want. So, okay, Helm is locked down. Helm is installed and not locked down. We'll run that Helm version again. And there we go. Both client and server are good to go. They're the same version. They're actually even built from the same commit. That's pretty rad. And I can't really stress how much like Helm install is cool. Helm init is cool. Because like you don't have to figure anything out. You download the binary, it's the CLI, and you just run a command and the CLI bundles all that crap up, all the YAML up and sends it up to the cluster. And so I kind of just did like 2 steps, essentially. I downloaded, or I guess 3. I figured out how to set my Kubernetes cluster up. That was that AKS get credentials. I downloaded Helm, and then I did a Helm init. So I did have to do some of that RBAC stuff. It wasn't absolutely required, but I've used Helm a bunch, and I know that there may be a problem coming. All right, so now let's actually make some magic happen. So we're going to head over to charts/proxy. Okay, we're there. I'm going to clear the screen, make this a little bit bigger, and make sure that didn't mess up my recording. It did not. I have a hotkey on my recording. It's Command plus and Command minus on the Mac. Command minus stops the recording, and it'd be a shame if I stopped the recording and then keep going. So I didn't do that. Great news. We are now in charts.proxy. This is exactly what you see here. And we're going to just take this for a spin. All right, so we have a few values. We've got a bunch of defaults. So this is the right registry, that's Docker Hub. This is the right repo, gomod/Athens. That's what we Docker pushed a while ago. This is the right tag. The tag changes, so we always want to have those Kubernetes workers pulling it down. This is all good. Storage type disk. I will store stuff on disk for now. Eventually, I probably want to store it in like MongoDB or something. And what else? Mongo storage URL. I actually don't care about this now because I'm storing on disk. I think I don't care about this. I don't 100% remember. So let's actually check. let's check out where that's used. So we want to exclude docs as well. I don't want to search for that in docs. I don't care about Travis right now. I don't care about my Kubernetes config right now because that's what I was just looking at. These .env files are for local development. And here we go. So we've got this function Mongo URI. Let's trace up where that function is used. Let's try this out. Find all references. I actually don't use this that much, so let's see if it works. And I'm impatient, so let's get rid of that. I don't know. I'll do it the old-fashioned way. Mongo URI. That's a test file. Event log is in Olympus. You can see there. I'm not deploying that. I'm not deploying Olympus, so that's not necessary. Here we go. So it's used here. It's used if I say storage type is Mongo, and I'm not. I'm saying storage type is disk. And then disk root. I definitely need to set that. That's in the env file. So Athens disk storage root, that's a thing. I need to set that. So let's go in and actually set that in our deployment. So we're going to set that there. And this is kind of like what we did with the Mongo thing. And in retrospect, I didn't have to do the Mongo stuff last time. But I think it probably ended up being good to kind of show how environment variables work in Kubernetes and Helm. So this is kind of the same deal. Name of the environment variable here, the value of it. We want to quote it in case there's some weird stuff that's going to mess with the environment variable getting passed into the container. And then we're going to go to our values.yaml. We're going to say disk storage root, and let's just say, I don't know, let's check out the Docker file. Let's just make it in /. I don't know what's going to happen with that, but we'll find out soon enough. And I go crazy with a lot of files, as you probably found out last time. I'm going to close all this down. Blah, blah, blah. And close that down, close that down. I had a lot open. Close the Docker Compose, lots of Go files. All right, good enough. All right, so I think we're all ready to go. We got some defaults. I don't need to set this because I am not using that. I'll just set it to like foo, just because I think that the container, I don't remember, but it's probably better not to send an empty environment variable in. So we're going to do helm install -- set. Actually, let's look at the help first. The help for helm. All right, there's a bunch of stuff here. But going up to the top, helm install is obviously the root of it. What are we looking at here? Helm install, this is what we want. We're setting a value on the command line. So that's good for stuff that's like secret or whatever. Or obviously you want to override. This is the actual chart. So charts can be on disk, which is this example. But they can also be like repository / something. And it kind of looks a little bit like Docker images. You install a repository before you do a Helm install. And like I was saying before in the Helm cache, the name of the repository, it keeps a mapping to the HTTP base URL to it. And that's about it. If you are in the local, or if you're in a particular directory, it's going to look at /redis under that directory. And by default, it's also going to look for the values.yaml file. And that's this. If you wanted it to look at a different file, you do -f. Right? But we're not going to do that because we have a values.yaml file all ready to go. So let's do helm install -f. And we will set Mongo storage URL to nothing. Let me refresh my memory in a new tab how that -f should look, or -set I mean. It should be something equals something. and that's -f is wrong. Mongo storage URL equals foo, and I just want to install it in the local directory from the local directory, so that's all good. But we can also do --name, and --name is the I like to call it the name of the release. I think Helm officially calls it that too. So if the chart is like a class in object-oriented programming, the release is like an object. And Helm treats releases as this like immutable append-only list of installations of objects. So I'm going to basically say this name is Athens proxy. And anytime I do a Helm install with --name equals Athens proxy, it's going to append a new release on the list of Athens-proxy releases. So that's nice, because then if you want to roll back, all it does is you can say like roll back to release number 5. All it does is it goes back to release number 5, grabs all the values from there, and then installs a new release with the same values from release number 5 as like n+1. So that means like if you're at 11, you say roll back to 5, it makes it 12 with all the stuff from 5. So that's kind of nice. You can also do namespace equals Athens. Let's just do namespace equals Athens. And that's about it. Dot, again, that's just like the local, the chart in the local directory. Okay, so let's do it. And there we go. All right, so what happened here? That's obviously the name. That's the namespace. It keeps timestamps for releases. The release status is deployed. And this is the stuff that was installed. So v1 beta 1 / deployment, that is the name of the Kubernetes resource. And that corresponds to this. So Kubernetes translates extensions / v1 beta 1 to v1 beta 1 / deployment. So it's the same thing, API version and kind. And then what it's saying down here is details of the deployment. So the pod name turns out to be Athens-proxy-Athens-proxy because name gets the template full name is Athens-proxy. And then we do the same thing down here. And when Kubernetes says what's the name of a pod in a deployment, it just merges them together, it munges them together. So now, if we go and check out, well, actually, one more thing. What's going on here, right? So this is saying we asked Kubernetes to create 3 pods with this spec in them. So it's 1 container, 3 pods with that container. But currently, right after I installed this thing, there were none of them. That makes sense because Kubernetes hasn't had a chance to do its thing. Up to date, I actually forget exactly what this means. And same thing with available. But basically, 1 second later, after I did the install, nothing was going on. No pods were running. But it's been a while, so let's go right into kubectl and check out what pods are running. So kget pods, PO for short. And remember, we installed a namespace Athens. So you can do -n Athens. And we got some pods running, but oh, that's not good. So we got to crash loop back off. And by the way, to make sure that the pod names are unique, Kubernetes deployments add some random stuff on the end. So I believe this is the hash of the deployment name. This is the hash of the pod. That's like a half-educated guess and half maybe I remember it right. So don't quote me on that. But obviously, like, they're all unique. Maybe this is the hash of the time. It's something that makes it unique, obviously, because you need pod names to be unique, just like you need deployment names to be unique. So let's figure out what happened with that crash loop backoff. So we can do kubectl logs, and then the pod name. And you can't do logs in anything but a pod name, but a pod. So you do kubectl logs pod name, and again, it's got to be in the Athens namespace. I'm going to clear the screen, and I'm going to go there. All right, so this is interesting. We started up the thing and error adding proxy routes. So obviously, like, these log messages could be better. They could tell me like a trace, like what function called this, or it could have a line number or something. But alpha product, we're kind of just not there yet. So let's just go into our code and search for what happened. So there. All right, add proxy routes, spit out an error. Error there, error was not equal nil, and then we did that. So let's go check out here. Add proxy routes, and the only thing that could return an error is here. So go get.new return an error. Okay. And here, the only thing that could return an error is module.new go get fetcher. Right, so this is really, really, really crappy debugging experience, which we obviously can and will make better. But so far, this is what we got. All right, so again, the only thing that can return an error here, valid go binary. And valid go binary, this is right here. Again, this is the only thing that can return an error. So we're trying to actually run, if I go back one, we're trying to run go binary name. And where did that get called? New go get fetcher, go bin. All right. So when we called new go get fetcher, we passed in go bin, and eventually down the stack, 2 frames down the stack, it actually tries to call that go bin. And when it tried to call it, there was an error, and the error was it couldn't find the go executable. So not the best. All right. So where is it getting go bin? Go bin path. So go binary path by default is go. And if I'm going to go back to the Docker file, my best guess is go is not installed. All right, so Alpine, APK add, some CA certificates. We just installed the app. There's no go binary. Okay, so let's go from there. And I've got about like 20 minutes left, so actually probably like 15 left. So we might not actually solve this today, but we're going to get a sense for how to debug and how we're eventually going to solve this. Okay, so again, the environment variable is go binary path. So we need to add go binary path to our deployment, and we need to be able to set the go binary path, and then obviously we need to build a Docker image that has go somewhere in the path, somewhere in the image, I mean. And then we have to be able to set go binary path in Kubernetes manifest, so that when it actually runs as a container, when the image actually runs as a container, it's going to be able to set that environment variable, and the program, Athens proxy, is actually going to be able to find the go binary path. Okay, so first things first, we're going to go in here and we say, oh, okay, great. Go binary path is already set as an environment variable. .values.go binary path is in here, it's being quoted. And let's go into values and see if that is in there. Okay, go binary path is set to go. All right, so what's going wrong? Let's go and actually debug this thing locally. We're going to do docker run --rm. That means that after I run my command in the Docker container, it's going to remove the image immediately, which is nice, saves some disk space. Okay, and the image that I want to run, go mod /Athens latest. That's the same one that's on Kubernetes right now. And let's start by doing this. Just running go. Okay, go. Executable file not found in path. That's same thing, right? Where did we do the logs here? So I'm actually going to copy this and put it into the other terminal. Same deal. Go executable file not found in path. So we're going to go and actually try to fix this. Let's go into our Docker file. And we've got this APK add. So that's Alpine package repository. So let's go check out that and see if we can install Go. Search for it there. And there we go. That's cool. right? We can, like the package Go, this is the Go programming language. Awesome. But here's a little piece of trivia. I actually kind of explained this last time. The Athens proxy uses Go modules on the back end to fill its cache. And unfortunately, Go modules are only available in 1.11 beta 1 and above. So right now we're at Go 1.11 beta 3. And there's no option here to install that. So bummer. Okay. But we have a way of installing that. Okay. So the first thing we're going to do is install Go 1.10 because we can compile 1.11 with 1.10. It bootstraps. So first things first, let's do an apk add Go. And we're going to do -- update Go. Okay. So we're going to actually test out this command right now, but we're not going to have to build the whole image. So I'm going to do this. Docker run -- rm. Instead of -- rm, I'm going to do -i for an interactive terminal and -t to get a TTY terminal. Okay. And then we're going to do this. Bash. We're going to try to run a bash prompt inside of our Athens. Cool. So where are we? /bin. Great. Okay. So let's do this. apk add -- update Go. All that good stuff. Got 1.9.4 going on. Sweet. We installed Go. That's the first step. We installed Go that can bootstrap Go. All right. Second step. How do we install Go 1.11? I think we've got some docs on that. And let's make this a little bigger. And since I'm paranoid, I'm going to make sure it's still recording. It is. It's that plus, man. Command plus. Let's check out development. And there we go. This is how we install Go 1.11 beta 3. So it's only 2 commands. That's kind of rad. So get that out of there. We're going to do a go get that. And all right, git not found in path. So go get that is using git to download code so it can compile it. So apk add -u git. Cool. So now let's run it. It's downloading stuff. And while we're waiting, we got to add this thing in too. And by the way, the -u it means update. And we don't have to update every single time. It's the same thing as -- update. We don't have to update every single time. We can just update once. But I'm doing it like this for now because I'm just used to it and old habits die hard. All right. So this is a problem, right? We tried to do it and then go get actually did a go build. But it's doing a go build expecting that we're on Linux with GCC, with the standard library. It's libc, right? So it's like we're expecting the standard C library on Linux. But Alpine doesn't run that, right? What's Alpine? This is Alpine. So Alpine is a Linux distribution and also a Docker base image that looks a lot like that Linux distribution. It doesn't have libc. It has Musl, M-U-S-L, which is a slightly different alternative that obviously go build does not agree with. So let's change this up, right? We don't have to build based on an Alpine image. I'm going to just build this on an Ubuntu image, Ubuntu 14.04. There are plenty up-to-date Ubuntus. This is what I remember off the top of my head. We'll go back through and fix pretty much all this stuff, all the APK adds and everything. But APK is not on Ubuntu, right? We have apt-get. Install -y bash. Okay. So before we go any further, I'm going to start up an Ubuntu container, and we're going to test these commands out. So I'm going to X out of that and go back to my Docker run. And let's just do Ubuntu 14.04 and then run bash. Okay, that's cool. So that means bash is already installed on that image. So I don't need that. CA certificates, those are root certificates. So anything that needs to talk to HTTPS server, it's going to need those. So apt get install CA certificates. Unable to locate. So apt get, I happen to know the solution to this is apt get update. So this grabs package lists from, I think like maybe 10 or 11, 17, 18, 19, 20. These are package lists from different repositories. 24 different repositories. Read them all, great. Okay, so now it knows packages that are in the trusted universe of Ubuntu packages. Okay, so now let's do apk, I keep doing that, apt get install CA certificates. Reading. Awesome. Do I want to continue? I do, but when I'm actually doing a Docker build, I don't want it to get hung up on this. Because I don't want to keep putting in yes. Actually, it will fail if I do that. So I'm going to hit no. I aborted it. Why am I here? I'm going to go back here. apt-get install -y will skip that. It'll skip waiting for me to just type y. So it's going to do the same deal. It didn't prompt me. It just said you hit -y, so I'm just going to keep going with it. And there we go. Almost done. Great. So we've got that going on. Run apt get update. Run apt get install -y CA certificates. And we need go and we need git. There's git. Go. Okay, let's just make sure those work. So here goes git. Lots of stuff. That's fine. And the reason I say it's fine is it's going to make the image bigger, and we can do tons of stuff to make sure the image is not so big. But for right now, I'm trying to get something working. And these images are going to be downloaded from Docker Hub into an Azure network. And those tend to be a lot faster than my Comcast connection. So I'm not too worried about this. Obviously, building the image is, as you can see, it's kind of painful. But again, that's going to be done in the cloud on our CI, on Travis CI. So again, like, it's inconvenient, and we will spend time making this better. But right now, I'm not going to worry about it too much. So there we go. Git is installed. Let's install Go now. I think this will be a little less intense. Unable to locate package Go. I think it might be Golang. And if not, I will have to go and search on the interwebs. Yeah, there we go. So I'm going to go back. Change that before I forget. Almost there, I believe. And this is cool. We've got Godoc. Godoc, Golang all, I think, is a bunch of plugins. Can't remember the rest. All right, so we've got Go and we've got Git. Let's check out Git first. Git is installed. Go is installed. Oh, 1.2.1. That's not amazing. I'm almost out of time. I'm pretty sure that is not going to be able to build 1.11 beta 3. So we might have to go and find like the right version of Go. But that'll probably be next time. So now that we do have Go installed, though, that's cool. And this thing, we can try to do our Go 1.11 bootstrap. All right, so we've got go get the whole URL. So we got that one. And then we can do go 1.11 beta 3 download, that was the thing that was installed from this go get. Okay, so first let's just try that in our terminal. And by the way, this is a, whoops, go path was not set. So let's do export go path equals /go. And we're just gonna do a make dir /go. You probably know go path if you are familiar with Go. Everything at the moment relies on go path. So that's all. That's cool. Let's do our go get. And if this succeeds, I would actually be pretty surprised. Let's cross our fingers. So it's, I believe at this point, yeah, I went out to the internet, grabbed that, built it. And this is a cool little tool. It's like a bootstrapping tool, but you don't have to like compile a ton of Go code to get Go 1.11 beta 3. We've got this tool, Go 1.11 beta 3. And the reason for that is it installed that Go 1.11 beta 3 into our bin folder. And there you go. Go 1.11 beta 3 download. And here we go. So let's about half done downloading. 3/4. Okay, it's all downloaded. It's unpacking the tarball. Not sure what you call a tar.gz. Tar.gz ball or something. Not sure. So let's see. We have Go 1.11 beta 3. Let's see, is that here? There we go. Go 1.11 beta 3 is there. It's in our go path /bin. And remember, we had to create a /go, and we had to set our go path. So let's go back and do that into here. /go and run make dir /go. Okay, and now we know that Go 1.11 beta 3 is our Go 1.11 executable, and that is this Go binary path. Okay, so let's go in here and set that to /go /bin /go 1.11 beta 3. Okay, so I am just about out of time for today. What I'm going to do is take all these changes. I'm going to go to my nice GitHub UI because command line stuff sometimes scares me at the end of the day because I've like taken down entire machines when I'm tired. I'm going to go to my UI. I'm going to commit all this stuff with a reasonable commit message. I'm going to push it up, and then we'll be ready for round 3 of all this fun Kubernetes-ifying adventure. So let's go here. What do I do here? I am going to start with a Docker file, changing to Ubuntu base image so that I can install Go 1.11 beta 3. This is used. So we have to do this. So that the proxy can use it to fill its caches on the back end. It's technically possible to use Alpine to do all that stuff, but it's harder because you need to configure Go. I can talk faster than I can type, huh? To build with Musel. Musel is that replacement / sibling of libc. So Go works just out of the box a lot better with libc. So that's a Docker file. And now we are going to commit this first because that's a simple one. Defaulting to or adding disk storage root environment variable in case you set the storage to disk. case you set the storage type disk, then you can set the storage root. So that one's pretty easy, pretty straightforward. And then here, I should have committed that with the last one. That's cool. Let's do this. Defaulting disk storage root location and go binary path. Defaulting to go binary path as installed a Docker file. Okay, so let's push that all up. Oops, we gotta exit our little Docker shell. So we got 4 bits ahead. We're gonna push it all up, and almost done, just about done. Okay, now we got those better commits, the more commits. Yeah, okay, so those commits are up. I'm pretty sure CI will fail again. I don't remember why it failed here, but it did. We didn't really do much more to make it succeed. But yeah, for now, we made a bunch of progress. We've got a Helm installed on our cluster, a tiller. It's the Helm server. We actually tried a Helm install. We found a bug. Actually, a little more than that too, because we found that we don't really have a good error message and a good way to debug what happened. I just happened to have some kind of tribal knowledge, I guess, that helped me do debugging. And so for now, like, we've got a good base. We kind of know how to improve our images. We kind of know how to like build new images now. We kind of know like how to do a little bit of Kubernetes stuff. We're making some progress. So that is it for today. Next time, tune in, and we're gonna get this stuff running on Kubernetes without failures or anything like that. And also, obviously, I changed a bunch of stuff, but I didn't update it in Helm. So we'll see how to do that. And again, fingers crossed, we might have been able to run like Go 1.11, like Go Get, and use Go modules to actually run a program. That might be asking for a little too much for a Friday afternoon, but we'll see. All right, so tune in next time. Take care, everybody, and we'll look forward to it. Bye.